In this work, we improve robustness in modular robot collectives. Scalable robot collective resilience by sharing resources. Scaling the number of agents reduces the reliability of the overall system. Natural and artificial colonies create resilience through sharing energy, communication, and sensing. Sharing resources increases system reliability with the number of agents. Even if 2 out of 3 critical resources are shared, the reliability still decreases as the number of agents in the collective grows. We reverse this trend, improving reliability with an increased number of agents through taking advantage of redundant resources and sharing them locally. A dead agent in a robot collective, without its own power, wireless communication, or sensing, remains fully operational thanks to our resource sharing method. In this experiment, the LED visually indicates that all of the central module's own capabilities are off. The central agent has no battery, wireless communication, nor sensing, but is completely compensated by its neighbors to achieve a locomotion task. To locomote via walking, all 4 modules are necessary. A single failure would break the system, with the central module being the most critical. With our proposed methodology, the neighboring modules bring the central dead module back to life by sharing all critical resources: power, wireless communication, and sensing. The system walks until it reaches a low obstacle, where it flattens and drives under. After, it stands up and continues to walk. This shows a contradictory result. An agent is effectively dead through lack of resources, but continues operating with its full capacity. Thank you for watching.